Hello students, today we are going to deal with a new concept of compound interest, that is growth and depreciation. It's actually a part of this chapter, compound interest. So the concept is growth and depreciation. Let us begin with what is growth. As the term denotes growth, we know that there are certain things that we see around us. They increase over time, they grow over time. Okay, so increase, another word for increase actually is appreciate over time. Like for example, the population of India, or the height of a plant, or weight of a child, and cost of goods. These are things we know that they increase or appreciate over time. So when such things appreciate over time, if the rate of the growth is constant, then the formula for growth comes as V is equal to V naught or V0 1 plus R by 100 to the power n, where V is the measure of the quantity after n years. V naught is the present measure of the quantity. So this V0 or V naught is the present measure of the quantity, and this is the measure of the quantity after n years. And this is the rate of the growth, and time is n years. So anything which increases over time, or it grows or appreciate over time, then we will use this formula V is equal to V naught or V0 1 plus R by 100 to the power n, where this is the present measure of the quantity and this is the measure of the quantity after n years. Let us take a small example like the population. So V naught will be the present population, and this will be the population after so and so years, whichever is mentioned in the question. Now, for successive rates of growth, the formula is V is equal to V naught 1 plus R1 by 100 into 1 plus R2 by 100. Now, successive rates of growth means over time. Suppose, for example, 2 years is given to you, and for the first year the rate of the growth is different, and for the second year rate of growth is different. That means for both the years the rate of growth is not same. It varies. Then we will use this formula V is equal to V naught 1 plus R1 by 100 into 1 plus R2 by 100, where R1% is the rate of the growth for the first year, R2% is the rate of the growth for the second year. Now we move on to what is depreciation. Depreciation, it is just the opposite of growth. Depreciation, there are certain things which decreases or depreciates over time. Like for example, the value of a vehicle. You buy a car now, and after 2 years you try to sell that car. Obviously that value of that vehicle will decrease or depreciate. Why? Because of wear and tear. So, or for any machine, if you want to sell it after some time, you have bought it for some value and you want to sell it after some time, naturally the value will decrease. So there are certain things which depreciate over time due to wear and tear. So that is called as depreciation. The decrease of value per year is called rate of depreciation. Earlier it was rate of growth, and here it is rate of depreciation. Now the formula is just the opposite of this formula. Here we have used plus sign, here we'll use minus sign. V is equal to V naught 1 minus R1 R by 100 to the power n. So students, try to remember the formula for growth as V is equal to V naught 1 plus R by 100, and for depreciation it will be V is equal to V naught 1 minus R by 100. Only in case of successive rates of growth it will be 1 plus R1, 1 plus R2. Here it will be R by 100, here it will be plus R by 100, here it will be minus R by 100. So growth and depreciation is a very easy concept. You have to remember this formula and apply it in the sums. I'll show you a single sum today for your reference.